Okay, so on page 89, we're going to be talking about addition and subtraction inequalities. So addition and subtraction inequalities are very, very similar to equations in that they have a different sign. Okay, you're going to treat them and solve them almost in the exact same way. So we're just going to put it in our own words, okay? So to solve, whatever you do to one side, do to the other side. Okay, so we're going to put it in our own words first, and then we're going to put it in more mathematical terms. So we're going to do the inverse operation. Okay, remember, inverse means opposite. Okay, if you want to put opposite, you can. So we're going to do the opposite operation to solve. Then we're going to cancel the one side, okay, and solve for the variable. But remember, with inequalities, we're not going to have just one answer. We're going to have a lot of different answers because we have a different sign. We have a less than sign, greater than, or less than or equal to, or greater than or equal to. So out here, I want you to put keep the sign. Okay, you're just going to keep the sign. Just like as we would if it was an equal sign, we're just going to keep that equal sign. So when we are solving this, this says something plus 5 is greater than 15. Okay, so this is a part, and this is your total, just as if this was an equal sign. All right, but instead of saying equal 15, we're going to say more than 15. Okay, above 15. In the word problem, it would say that. So we're going to do just like we did, the same method as we did when we were solving equations. So we're going to look for our sign, and we're going to separate this side of the inequality from this side of the inequality. We're still solving for x, but we're going to keep this sign. Okay, we're just going to bring it down and write it exactly the same way. So I want to get x all by itself on this side of the inequality. So I need to get rid of plus 5. Okay, the opposite operation of adding is subtracting. So what I do to one side, I do to the other. Okay, we have plus 5 minus 5, that's 0. There goes your canceling. And now this tells you what to do. 15 minus 5 is 10. So whatever number I put here, in order to satisfy this inequality, x has to be greater than 10. So I could do 10.1 or 10.2 or 11 or a million or 18. All right. So when I graph it, just like yesterday, and again, you can number your number line however you want. I just put 10 in the middle. So since this is a greater than sign, it's going to be an open dot on 10, and then we are going to go greater than. So all the numbers that are greater than 10 are over here. So we're going to graph it just like that. All right, so let's look at this one. We have 76 plus y is less than or equal to 185. So we're going to draw our line, and we're going to solve for y, and we're going to keep the exact same sign. How do I get rid of plus 76? I subtract 76. What I do to one side, I do to the other. This cancels. And so now I have y needs to be less than or equal to 109. So again, I'm just going to count by ones, but since the numbers are larger, I'm going to label every other one. So since this has an equal to sign, it can be equal to 109. So we're going to do a closed dot on 109, and we want it to be y to be less than 109. So we're going to go put our arrow this way. Okay. To get a free meal at her favorite restaurant, Gina needs to spend $50 or more. So that means $50 or 51 or 52 or 53 or $50.01, okay, or more. She has already spent $39.26. How much more does she need to spend? So to me, that sounds like a subtraction problem. My instincts are telling me to subtract to solve that. But these words right here tell me that it's an inequality. I'm not going to just put an equal sign. So I'm going to think, okay, well, this is going to be my total, 50 or more. This is my part. Okay, I'm going to put X as my other part. So if my instincts are telling me to subtract to get X, and these are my two parts, and this is my total, I'm going to say X plus $39.26 does not equal, but is 50 or more. So that means it can equal 50 or be more than 50. So now I've written my addition equation and I can solve it. So I'm going to draw my line to separate this side of the inequality from this side. I'm going to keep my sign. I'm going to solve for X. How do I get rid of plus $39.26? I subtract $39.26. Don't forget, with money you have to line up your decimals when you're adding and subtracting, or with any decimals. So now we have, so X is, I'm going to have to spend $10.74 or more. So that's my answer. I don't just have one answer because of those two words. That changes everything. So one, at most, there's my words right there. So if you need to look back on page 87 and look at what at most means as the sign, you can. So Juan has at most $12 more than Chad. Chad has $36. How much does Juan have? So Juan has more than Chad. We know Juan is the bigger number. Okay, Juan is the total. So I'm thinking that my instincts are telling me to take Chad's and add 12 to it, and then that's how much Juan is going to have. But it's not going to be an equation. I'm going to have to use a sign that means at most. So if my instincts are to add, I'm going to write a subtraction inequality. So X minus 12 is at the most, so that's going to be less than or equal to 36. So there's my subtraction equation. I'm going to solve for X. Do the opposite of subtraction, which is addition. So now I have minus 12 plus 12. I'm at 0. So now this right here tells me, and I'm doing what my instinct told me to do originally right here. So now when I add, so Juan has $48 or less compared to Chad. So Chad had 36. Juan at the most has 48 or less because he has at the most 12 more than Chad. So the difference between Juan and Chad is at the most 12. Okay? All right, so let's look on the back. Number 1. Leonie needs to collect at least, oh, there are my words, at least 12 rocks for a science project. She already has collected 5 rocks. The inequality shown can be used to find in the number of rocks that she still needs. Okay, so since that was my total, my instinct was to subtract in order to find how many rocks she still needs. Okay, so that's why we wrote an